Imagine that you've been assigned a group project. It's a big project, so you're going to split up the work and you'll be working separate parts from home. It'd be great to have a place for your project to live so that everyone can easily access it. It'd also be great to be able to track all the changes that you've made to the project. So what your group needs is a repository, a home for your project, and a version control system, software that will help you maintain a history of your work. Now your group can work together all using the same files. You can request a copy of the latest files at any time, and when you make changes, you can move those changes over to the repository. You can even add a useful comment to explain the changes that you've made. And when two or more people have conflicting code, it can be pointed out to you line by line so that you can reconcile those differences. So with a version control system, or VCS, you can keep a history of every file in the project, revert files back to a previous state, compare changes over time, see who last modified a file, and more. So if you haven't used the VCS before, now is a great time to learn because you'll be using it not only in the lab, but in most software development environments. There are many version control systems out there, but the one that we'll be using in the lab is called Git. But before we start using Git, there are two key concepts that I'd like to quickly go over. The first concept is Git thinks of its data like a series of snapshots. Every time you commit or save the state of your project, Git basically takes a picture of what all your project files look like and stores a reference to that snapshot. If files haven't changed, then Git doesn't store the file again. Instead, it stores a link to the previous file it has already stored. By capturing the state of all the files in each snapshot, we can see what the project looked like at these moments, and we can revert files back to the previous state if we need to. The snapshots begin to build a history of the project, and as the project evolves, each part of its current state can be traced back in time. The second key concept is that Git generally only adds data. It's difficult to do something that is not undoable or that will erase data in any way. And this is nice because you can work on your project and know you can always go back and undo if something breaks. There are different ways of using Git, including graphical user interfaces, but we'll be using the original command line tool. Git is pre-installed in your VM, and we can tell this by typing Git and hitting enter. You can find a free online book on Git directly on the Git website, and I encourage you to take a look at it because it covers most of what we'll talk about today and a lot more. So you might be asking, what does GitHub have to do with all this? With a version control system like Git, you'll typically have a server that contains the project files, and you have clients that connect to that server to access them. And this is where GitHub comes in. GitHub is a Git repository hosting service, and you'll be using GitHub to host your future projects. Now that we've covered some background, I want to go over the average workflow you'll be encountering. Here I have a project on GitHub. The repository already has some files to get me started. This repository is private, so only I will have access to it, but soon you'll be receiving an invitation to create your own repository for the first project. I'd like to obtain a copy of this repository so that I can take a look at it and work on it some more. The Git command that we need is clone. We follow clone by the location of the repository and the directory we want to clone it into. When it comes to GitHub projects, its location is given by its web URL, and you can find this URL by clicking on the clone or download button. I want to clone into this directory, so I'll hit enter. Make sure you're connected to the internet, and you'll be asked to authenticate. Your username and password are what you've been using to sign into GitHub, and now if everything goes as expected, you'll see this done message. So at this point, you've downloaded the entire history of the project, and I can change my working directory to start looking at the project files. If I enter git status, you'll see that we're up to date and there's nothing to commit. I just cloned the repository, so all the recent changes are in my local copy, and I haven't made any changes, so there's nothing to commit or take a snapshot of. I know I'm going to be working with Emacs a lot, so I'm going to open that up and work from there. I'm going to start by adding a new file, a tiny hello world. I'll open helloworld.c. Since it doesn't exist, it'll be created for me, and I'll type up my program and save it. I'll open up the shell and enter git status again. You'll see that I have a new untracked file, helloworld.c. This untracked file is not part of my project yet, and if it remains untracked, then I won't be able to track its changes. So I'll start tracking this file by using the add command. If I enter git status once more, you'll see that the file is now under changes to be committed. At this point, I can commit. I'm going to follow the commit command with the -m to add a message, something like edit helloworld.c. If this is the first time you're using Git on the machine, you'll get a message that says, "Please tell me who you are." And it says to run 2 specific commands. You want to run those 2 commands one after the other, replacing your email and name where necessary. If you run the commit command again, you should see the message you want. You'll see the commit message and the changes that have occurred. Now I want to make another change. Let's say that I want to change how my Hello World program works, and I want to update the README to include this information. First, I'll update my Hello World to output a second message. I make that change and save the file. Now I'll open up the README, make that change, say helloworld.c is a simple Hello World program, and save that file too. If I go back to my shell window and enter git status, now you'll see some changes not staged for commit. I've modified readme.md and helloworld.c. Because I want to include these changes in my next commit, I'm going to use git add to add both of those changes to the staging area. I'll run git status again, and you'll see that the changes are now under changes to be committed. I'm going to commit those changes, again using the git commit command, adding a helpful message. Now if I go to the GitHub page for my repository, you'll notice I don't see any changes when I click onto this commits page. And this is because I haven't pushed or sent over my changes. And doing this is pretty simple. I'll go back to the VM and use the push command. If that's successful, then if I refresh this commits page, you'll see my commits. Here's my first, and here's my second. If I click onto one of these, I can see the exact changes that occurred. I can also see these changes from the shell, either by using git log to view the commit log, or by using git show to view the changes for the commit. Now, if you were paying attention to my code, you might have noticed that I made a mistake with my print statement. This line will result in an error, so I want to undo my last commit. This is something you should be careful for, but people make mistakes and it happens, so there's an easy way to undo this. We talked about how Git generally only adds data, so my next commit will actually undo the previous commit. I'll type git revert head -- no - edit. I'm entering the last option so the commit message editor doesn't pop up. Now if I push again, I should be able to see those changes from the GitHub page. Going into the commits page, you can see how my last commit has basically undone everything that the commit before it did. So those are the basic Git commands you'll be using for the lab. This is just a subset of the many ones available, and even the ones I've shown you here today have several options that you can play with. If you have any questions, feel free to ask one of us, and if you want something to read, be sure to check out the book on Git's website.